Let us discuss about one of the most important battery, that is nickel metal hydride battery. It is a secondary battery with a cell potential of 1.2 volt and energy density of 94 watt hour per kg. It has a better cycle life and high power density of 200 watt per kg, which makes it highly useful in automobiles. Construction. The cathode in the nickel metal hydride cell is a highly porous, sintered or felt nickel substrate into which the nickel oxyhydroxide is impregnated or pasted. The anode is highly porous structure with a nickel wire gauge grid into which the plastic bonded active hydrogen storage alloy is coated. Two types of metal alloys are used: AB5 class of alloy, which consists of lanthanum and nickel, and AB2 class of alloy, which consists of titanium and zirconium. In this battery, potassium hydroxide is used as the electrolyte and a synthetic non-woven material which serves as an insulator between the two electrodes and a medium for absorbing electrolyte, acts as a separator. In conclusion, the anodic material is active metal hydride, cathodic material is nickel oxyhydroxide, which contains nickel in plus 3 oxidation state. Electrolyte is 30% potassium hydroxide and the separator is polyethylene or polyvinyl alcohol. This is schematic representation of nickel metal hydride battery with all its important components labeled. Working. Under working, we are going to discuss about the cell representation, anodic reaction, cathodic reaction, and the overall reaction. Cell representation of this battery is given as MH, where MH is metal hydride slash KOH 30% slash NiOOH, NiOH twice. At anode, metal hydride reacts with hydroxide ion, giving metal M and liberating H2O and one electron. H2O passes through the separator and the electron moves through the external circuit, and both of them will come in contact with the active material at cathode, that is nickel oxyhydroxide, and they form nickel hydroxide and regenerates hydroxide ion, which is utilized at the anodic reaction. Here we can see that hydrogen changes its oxidation state from -1 to +1 at anode, and nickel changes its oxidation state from +3 to +2 at cathode. The overall reaction here is MH plus NiOOH gives M plus NiOH twice. The open circuit potential of the cell ranges from 1.25 to 1.35 volt. Applications of this cell are in consumer electronic devices such as cellular phones, computers, camcorders, and other portable applications. Apart from this, it is also used in electrical vehicles. Now, let us discuss about one more battery, that is lithium ion battery. Lithium ion batteries are secondary batteries. That means they are rechargeable. A typical lithium ion battery can store 150 watt hours of electricity per kilogram of battery as compared to other batteries like lead acid batteries, which can store only 25 watt hours of electricity per kilogram. You can see the difference. In case of lithium battery, it is almost 6 times greater compared to other batteries. Normally, all batteries suffer from self-discharge. That is, they undergo self-discharge when they are not being used. Same is applicable to lithium ion batteries as well, but it is very less. It will undergo self-discharge hardly 3 to 5% over a period of 30 days of storage. That is one more advantage of this lithium ion battery. Now let us discuss the principle on which the lithium ion battery works. Here we have anode and cathodic material which are having the layer structure, and lithium atoms can be inserted between the layer structure. Normally what is happening during charge and discharge process here is either the lithium atoms are extracted or inserted from these interstitial spaces of the atomic layers within the active material of the battery. Here simply lithium ion transfers between anode and cathode through the lithium electrolyte. Since neither the anode or the cathode materials essentially change, the operation is safer than that of a lithium metal battery. This is a schematic representation of lithium ion rechargeable battery. Let us discuss about the construction. Lithium ion cell has four layer structure. A positive electrode, that is cathode, which is made with lithium cobalt oxide and has a current collector made of thin aluminum foil. A negative electrode, that is anode, made with lithium atoms intercalated in layered graphite and has a collector of thin copper foil. A separator is a fine porous polymer film which is either polyethylene or polypropylene. An electrolyte made with lithium salt in an organic solvent, particularly LiPF6 dissolved in a mixture of organic solvents like propylene carbonate, ethylene carbonate, 1,2-dimethoxyethane or dimethyl carbonate. The electrolytes are selected in such a way that there should be an effective transport of lithium ion to the cathode during discharge. This type of conductivity of electrolyte is ionic in nature rather than electronic. Now let us discuss about working. The cell representation for this cell is given as Li slash Li plus, comma C, where C indicates the carbon which is making the graphite, slash LiPF6 in ethylene carbonate slash LiMO2. During charging, lithium in positive electrode, that is cathode material, is ionized and moves from layer to layer and is inserted into the negative electrode, that is anode. During discharge, lithium ions are dissociated from the anode and migrate across the electrolyte and are inserted into the crystal structure of the host compound of cathode. At the same time, the compensating electrons travel in the external circuit and are accepted by the host to balance the reaction. This process is completely reversible, thus the lithium ions pass back and forth between the electrodes during charging and discharging. The chemical reaction that takes place inside the battery is as follows. During discharging, at anode, lithium atom which is inside the graphite layer, it will get ionized into lithium ion and liberating electron. Thus it vacates the graphite layer and the lithium ion starts moving towards the cathode internally through the electrolyte and the electrons move externally to the cathode. At cathode, the lithium ion and the electron, they combine and they get interconnected into the metal oxide structure, which is indicated by LiMO2. So these two reaction takes place during the complete discharge of the battery. Once the battery gets completely discharged, we are going to charge it. Now, when we are going to charge the battery, the role of the anode and cathode will get interchanged. Earlier, during discharge, lithium in graphite layer was acting as anode and lithium intercalated in metal oxide layer was acting as cathode. Now, during charging, lithium inside the graphite layer will act as cathode and lithium intercalated inside the metal oxide layer will act as anode. Let us see the reactions now. At anode, LiMO2 gives Li plus ion which moves internally through the electrolyte to the cathode and the electron will move externally through the circuit to the cathode. At the new cathode, that is graphite layer now, Li plus ion and electron will combine to give the lithium atom which gets intercalated inside the graphite layer. The net cell reaction here is LiC6 plus MO2 gives LiMO2 plus 6C. Applications of lithium ion battery. The lithium ion batteries are used in cameras, calculators, cardiac pacemakers, and other implantable devices, telecommunication equipments, portable radios and TVs, laptop computers, mobile phones, and aerospace applications. Thank you.